Okay, welcome back and integrating inverse trigonometric functions. And like when we were differentiating, you have your standard differentials and integrals, and you may be asked to show how these results are obtained. So we need to be able to show that clearly. So integrating with integrating the inverse trig functions, I call this A and B because these are your standard results. But going back to the last port of call, when you were differentiating inverse trig functions, arc sine x was equal to 1 over 1 minus x squared, and or the root of 1 minus x squared. Of course, the reverse process of this integration will give you arc sine x, and similarly the integral of that should give you arc cos x, and the integral of 1 over 1 plus x squared should give you arc tan x. And of course all of those are your standard integrals. It's just the reverse process, but we need to be able to show that. So let's have a look at A, which is going to be the integral then of 1 over the root of 1 minus x squared. 1 minus x squared, because we've got two results here, and arc tan x and arc sine x. So let's deal with the arc sine x. In fact I've got it the wrong way around. A and B, one is arc tan x and the other one is arc sine x. So I should actually let's have a look. So 1 second. Where's the let's change it around. So it's actually BA, but never mind. It's actually B and A. Okay, so that's A. 1 over the root of 1 minus x squared, and so let's substitute. So we're going to subst x equals to 0. Sorry, I apologize. X is equal to sine theta. X is equal to sine theta. Don't know where I got 0 from. X is equal to sine theta, and then of course dx d theta is equal to cos theta. And dx, I can put therefore dx will be equal to cos theta d theta. So once we've attained that, we know that x squared is equal to sine squared x. So we go back to our integration, and of course this will give me the integral of 1 over, and I'm going to replace that 1 minus with the root of 1 minus sine squared theta with the root of cos squared theta, with the root of cos squared theta, and then multiplied by cos theta d theta. And sorry, we're not there yet. Okay. Yeah, so now of course these cancel each other out. That's nice. So I'm left with the integral of 1 d theta. The integral of 1 d theta is equal to just 0 plus c. Now if x is equal to sine theta, the inverse we inverse sine theta to make theta the subject, and if we do that we end up with the answer of arc sine x plus c, and that's the answer to A or B, whatever. Now B, we're going to deal with tan, so that will be the integral of 1 over 1 plus x squared, so dx. And similarly we're going to subst x equal tan theta. And dx d theta, of course, dx d theta will be sec squared theta. And therefore dx will be equal to sec squared theta d theta. Now, going back again, like before, same process skills or same procedure, we got the integral of 1 over, now x is tan theta, so x squared is going to be 1 plus tan squared theta. So we've got 1 plus tan squared theta, and that should be a plus. And then multiplied by sec squared theta d theta. And then we know that this is the integral of 1 over, because 1 plus tan squared theta is identical and equal to sec squared theta. So we put that, we use that identity, and oh, that's nice. We've got things to cancel out. Like before, sec squared theta cancels with sec squared theta, and therefore I end up with the integral of 1 d theta. And we're almost there, as showing as a proof. And let's get rid of that. I've worked on that board before. Apologies for that. So that gives me, like before, 0 plus c. And again, x is equal to tan theta, and then we just arrange it to make theta the subject, and that will give us arc tan x plus c. Okay, because that's just the inverse. And that's how we show that these identities are met. Going back to here. And that's how you do.